Hey, what's up guys? It's Snortrain, and today I'm going to show you how to do a more efficient circuit for backup power. Now, I will leave a link in the description so that you guys can skip forward to the answer if you're that kind of person, but I'm going to try to go through this and really explain the details so that you can do whatever you want to expand, change the design, whatever works for you. First off, I'm going to start with the problem I have with the circuit that you see a lot. And it goes something like this, right? You've got a blocker. We're just going to do it with one battery for now. You've got a blocker. You've got an electrical branch. You've got another electrical branch. You've got an OR switch, which, oh yeah, that has to go on a wall. So there you go. And it goes a little something like this. Let's say my base needs 40 power, right? So I'm going to say that's 40, and there's some additional. Then I go here and I say, all right, 40 and some additional, so I'm going to make this 43, and that'll give me the excess for the power out on top of the branch. And that excess on top will go here, and that's going to block the battery, right? Then, from here, right, you got that 43. It's going to go to the power in here. Then on the additional power out, right, you're going to go here and charge the battery, power in, right? So anything additional we make goes over here and charges the battery. Anything less or anything under that 43 goes over here. We're using one to block the pass-through. We're using another one, right, to actually charge the base. So go here and actually let me do this first just so we can see the power. And we're going to go ahead, power A we're going to do with this. And then we have this here and here. And the other power out is going to go to B. Now let's make that clear here. Alright, that's how that'll go. And then the last piece of the puzzle is this, our main power, right? So we've got enough power, goes here. We end up charging this, right? So we're charging the battery. We have the power in here coming from the battery. It's blocked, right? This goes into this, and if I go ahead and show pass-through, we have 39, which we'll just say that that's enough for the base. I could also make this just 41 because the OR switch will use 1, right? That'll still keep that blocked. All right, we're good. So this makes sense. It works. It does the job. Not a big fan though, and this is why. So let's look at the situation where we don't have enough power. In order to recreate that situation, I'm going to use an electrical branch. I'm going to clear that, put this into the electrical branch. I'm going to be able to set this, so let's say for now we have 50, which is enough, right? And I'm going to use that in order to power the primary electrical branch and show you what happens. So the power out on top of this, right, is going to go here into that. Now for making it very clear what I'm talking about, I'm going to include a counter here. And this is going to show pass-through. This is going to actually show what input A, right, which was this branch out. We're going to have this show what the branch out is actually putting out. And I don't want that. Alright, so we are charging this, that's all fine. This is blocked right here, so we don't need to worry about any of that. It works, right? So now let's replicate the case that we don't have enough power going in. We only have 40, right? Now what happens? This is no longer blocked, which is good. You know, that's what you'd expect. And we see that we have base power. But look at this. 38 power is still going in to the OR switch. You can probably see the problem with that. We're wasting all of this power going into here because the OR switch only takes from one source. So you can see that coming out of this is 99. It'll take the greater of the two, as is in the description. This is not good. So let's go ahead and make a better version of this circuit. I'm going to show you guys how to do what is a circuit that uses that power and uses a redirection with the memory cell in order to not waste anything. And it's not too complicated, but it will take some brain effort on your part if you aren't familiar with electrical flow or any of that. So first off, what you need 4 electrical branches. You need a blocker, memory cell, and 2 OR switches. These are just things that you use for your power adapter. I'm going to show you this with 2 batteries. You can do it with 1 if you want, without too much hassle. So first off, let's put down the root combiner. So we'll just use power from 2 sources so you can get an idea of the power that you're really saving here by using a circuit like this. And then combine power, and let's set that to 60 for now. All right, so actually let's set that to 100 for now. So first off, we're going to throw up the electrical branches. I'm not going to be very neat about this, but hopefully you'll still get the point. We do need 2 OR switches. One of these OR switches is going to be for using 2 different sources to power the batteries. The other is going to be using 2 different sources to actually power the base. First off, let's start with the power that we actually need to go to the base. So it's you need to figure out what your lights need, what your auto turrets need, whatever it is, and start with that. What you're going to do is whatever it is, let's say it's 40, right? You're going to need to take that number, you're going to need to add 1 to power the memory cell, right? You're going to need to add another 1 to power the OR switch, right? So we'll start with that. Right. Now the branch out is going to go to powering the memory cell. There you go. Now the power out, so that'll be anything additional on top of this 42, right? That needs to go to actually blocking the battery. Here. And right. Now, another piece of the puzzle, we have this guy. So we had to set this to 42. You want to set this so that you have enough to do this 42 plus the extra 1 it takes to power the electrical branch plus the extra 1 it takes to block the pass-through. So realistically, what you want is 42 plus 2, 44. All right, so 42 here. So we start with 40 to actually power the base, 42 here to power the base and block the pass-through for the batteries, and then 44 here. So the branch out will give us enough here to do that. The power out, though, on the other hand, that needs to go to doing something else. So in order to have the memory cell go to the right location, we need to use the set and the reset. Now the set, what it does is it makes sure that the power goes through the output. The reset makes sure the power goes through the inverted output. So whatever is coming through here, that's how it's directed. All right. So now we need power coming into this. So the next part is how we make sure that we have the additional power from this going into the batteries. So if this requires 44, right, we need also another one here to set the memory cell. So this is 44, it's 46, right? So we say that we need 46, and the 46 is the 44 from this, right? Plus the 1 for the memory cell, plus the 1 for the electrical branch. So the branch out there is going to go to powering this. The configuration for it is going to be 44 plus 2, 46, right? And then the power out from this is going to go towards charging the batteries. So the batteries can get charged from 2 locations is the idea. So put that on input A, right? Now the other thing, so the other place where the batteries will get power from is the main power when it drops below the threshold. So if this is set, that means we have enough power, and that means that the output will be set, and we'll want the output to go to the primary base power. Now if we don't have enough, we want this power to go to charging the batteries instead of being wasted, right? The total of this power is going to come over here. It is going to go into the batteries. Now, it used to be that you needed to use a splitter and go through both the batteries and charge them at equal rates, or you could set up like a clever counter. You don't have to do that anymore. If you aren't aware, they changed it so that you can wire batteries in tandem now. So you can have this one go to that one. It'll charge this until it's full, and then it'll stop being charged, right? So that's how that works. This is all right. The other thing is that you need power coming from the battery. So this is base power, right? If we have enough, we charge this and we get it. If we don't have enough, though, we need to get it from another source, and that'll be what comes out of here. Now, you would want to put it on the blocker. There's a problem, though, which is the batteries actually need to do the reset of the memory cell. So what we're going to do instead is we're going to configure this for 2, which is fine. And we're going to have this guy go ahead and do the reset here. We're going to have the power out go to the main power, and we're going to have the power in from that actually come from the blocker. Right? So that's how that works. Now this, just to see an illustration of what happens here, we're going to take this and we're going to power in, and we're going to show pass-through, right? That won't get powered yet. We're going to take this, branch out, yep. And we're going to see that this circuit actually works, all right? So you see we're coming from input A here, which means that this is set, right? We have enough juice, so that's happening. Power out. Here, we have 41. We're good. You can see this is getting, this is actually draining. This is getting charged up, though, by that. We're going to go ahead and put a counter in this circuit so that we can see what actually happens with the excess power when we run into the same situation as before, where we're not getting enough. So if we look at the power here, right, this is the base power. We're going to clear this. Sorry, that's not the base power. That is the power that's being it's coming from the generators. So we're going to show a pass-through, and we're going to have this actually go to the memory cell. So you can see this is 42, right? We're having that go here. Nothing's being wasted right now. And you can see that this is charging this, right? Not very high though. Let's set this to, can we do 200 on one of these? Sweet. So now it's charging it much faster. You can see how that works right there, right? So this is the ideal situation. You can see that out of this we have that 40, right? And it comes into here, okay? So now what we're going to see is what actually happens, right? This is the output. This is what's charging this. So what we're going to do is clear this branch out from going to there. We're just going to go straight to the memory cell again, like we were before. And then what we're going to do is take this output, right? And we're going to have that go to the counter so that you can see what actually happens in relationship to the primary base power. So when we have enough, we have that 42, all looks good. We're getting power out from the OR switch. So now we're going to recreate the situation where we lose power. Before we do that, we're going to go ahead and make sure that the blocker actually gets power in from this so that the passive can be activated, right? So you can see 42, that's going to get reset by that electrical branch, which is getting nothing. So now let's set this to 35. So we don't have enough power. Now you can see that the base power is coming from another location. You can see that's 95. But you also see that this has been reset and the inverted output is going instead. So the primary output is blank. But you can see that this is getting power because it's actually charging this, right? So every time it gets power, it gives it a little boost. So kind of a slow charge there, but you are actually charging the batteries, right? You're extending the life of the batteries instead of wasting whatever that is. So now let's get into a situation that's maybe more likely for you big teams or whatever that are, you know, going crazy. Let's say that we don't have 42 required. Let's say we have like 100 required, right? So this bumps up to 102, and this bumps up to 104. 104, right? So yeah, sweet. So now that we've set those, you can see that's still reset. We still have, you know, power coming out here. Let's set this to 150. And you can see that now that we have enough power, right? 100 is coming from this. The batteries are being charged by the additional, right? Now let's go ahead and see what happens when we get below. So if it's at 100, right? If we drop down to 90, normally we'd be wasting that power, right? But now you have those 90 volts actually going into here and charging this, right? And that's a lot better for people who skipped all the way forward and just wanted to see what the actual circuit is, right? I'm going to leave the counter in there. I will, however, clear the output, make it obvious. Okay, so the circuit is your primary power in, wherever it is, goes to an electrical branch, right? You've got 3 electrical branches, all of which the branch out goes into the next electrical branch, right? Except for this one, where the branch out goes to a memory cell. Set your primary power +2 here. Set your branch power here +2 in this one. and then the branch power here plus 2 for this one. The output, power out, here goes to OR switch 1. The power out here goes to the, very important here, goes to the set of the memory cell, right? And then the power out here goes to the input for the blocker. All right. Let me get this back up to something where it'll charge. So then you have the power out, or sorry, the inverted output of the memory cell, which will go, as you can see, to the OR switch 1, right? You have the output of the memory cell, which will go to input A of OR switch 2. You have the output of OR switch 2, which goes to your main base power, so we're just hooking up to this counter for now, right? Then you have batteries. So you have battery 1 output into battery 2. You have the input of battery 1 coming from OR switch 1. You've got the output of battery 2 going into the input of the blocker. You've got the power out, right, of the battery going into the electrical branch of the 4th electrical branch. Okay, you got the power out going into OR switch 2. You've got the branch out, right, and this is configured for 2, so you've got the branch out, which should just be 2, going to the reset of the memory cell. Okay, and then you have the block for this, right? That is coming from, as you can see, the power out of the 3rd memory cell. Okay, that's the circuit. Pretty simple. You can hook it up to whatever your normal power out is, and what you'll end up with is a base that doesn't waste power. Once you drop below your power threshold, it actually reroutes it into the batteries and extends the life of them. So that's it. Hopefully that makes sense. Any questions, leave them in the comments. If you have any requests for other circuits that you want to know, feel free to leave them in the comments as well. I'll check and try to update new videos with other circuits that are cool. Next week I'll be putting out a video on the real foolproof trapdoor. So best of luck, guys.